One of the greatest hazards at sea is fire on board ship. Even a very small fire in a waste paper basket can grow into a major disaster. Fire prevention is therefore one of the main responsibilities of everyone on board ship. The first step in fire prevention is the understanding of fire, which leads towards understanding what fire prevention really means. We know about the fire triangle, the simple theory of 3 sides or requirements necessary to produce a fire. Something that will burn, fuel, the source of ignition, heat, the support for combustion, air. Bring these 3 components together and we have fire. Separate them and no fire. This is the essence of effective fire prevention. That is, recognizing the fire hazards in everyday situations where all these 3 elements exist in the right conditions and the right proportions for them to cause a fire. Fire is a chemical reaction between a flammable material and air with the production of heat and light. The sources of ignition are numerous: a naked flame, a spark from friction, or from electrical apparatus, or impact, such as dropping a spanner on a steel surface. Sparks from electric or oxyacetylene welding, a lit cigarette, funnel sparks, a non-safety match rubbed on a rough surface or trodden on, a spark from static electricity. The ignition sources you have seen, and many others, can ignite by direct contact with a substance that will burn in the presence of air or an oxidizing agent. The heat can also be transferred by 3 other means: radiation, conduction, and convection. Radiation transfers the heat through air or even through vacuum. The sun's rays can cause fire, especially if focused through a lens or even a cracked porthole glass. The heat from a grill. There is no direct contact. The heat is radiated, but it can still ignite the toast. Radiated heat can be from something that is not hot enough to glow, but it can still set fire to flammable substances. Conduction is another way by which heat is conveyed from the iron element, in this case, to a shirt. And although there is no direct flame, the shirt could ignite. Arc welding is going on here, as you see. The heat could travel through to here. The paint blisters. A cloth draped over a bare lamp. The heat is radiated from the filament to the glass and conducted to the material. Its composition changes and it spontaneously ignites. The heat from hot bearings may travel to some other part where the presence of hydrocarbon vapor from a leaking gland might be ignited. Chip fryers, pans, all rely on conduction to transfer the heat from the heating element to the substance to be heated. Convection is the third way by which heat can be transferred and is the way many heaters work. The air is warmed and rises in the room. If the heat is concentrated in one area, the air can become so hot that ignition of a flammable substance can occur. The cooker ventilation hood is taking away convected heat. If the inside of the hood is allowed to gather grease and dust, this may readily be ignited by the hot rising air. Looking now at another side of the fire triangle, fuel. Flammable substances tend to fall into groups. Carbonaceous substances, such as wood, paper, most bedding, curtains, packing cases, are substances which may be found in many parts of the ship. Another group, volatile liquids, are made up of substances such as petroleum spirits, paints and oils, paint thinners, kerosene, and others. Another group is flammable gases, which on most ships would be acetylene and propane gases, and in specialized tankers may be liquefied gases at low temperatures, such as LPG or LNG. Electrically caused fires do not really constitute a class by themselves, as electricity is a heat source and not a fuel. But they do require special treatment and isolation. Despite what is generally thought, when combustion takes place, even of apparent solids, it is the gas or vapours given off by the product that burn, and not the solids as we see and know them. Wood in this instance. If we try to set a block of wood on fire, it is difficult. Pair the wood and it becomes easy because we're exposing a larger area to the heat and it vaporizes more rapidly. Loose material left lying about behaves just like that. And if we actually make the wood into a powder, it even flashes. And remember, vapors don't necessarily stay put. They can travel, and if they find a heat source, flash. Talking of flash points, here we have oil in a beaker at normal temperature. It won't ignite. The flash point is the lowest temperature at which a product gives off sufficient flammable vapor which will flash if a source of ignition is introduced. The ignition temperature is that at which the substance, when ignited, will continue to burn, usually only a few degrees above the flash point. If the oil is heated to a still higher temperature, it will self-ignite, and this is called the self-ignition temperature. Knowing something of the causes of fire helps in understanding something of the prevention. To start with, a very basic contribution to this prevention of fires on board is good housekeeping. This includes good lighting, cleanliness, general care, and keeping things in their proper places. In relation to this matter, the Code of Safe Working Practice or the company's safety manual are valuable. The galley is a source of potential risks. A cloth on a hot plate which should have been turned off. Oil in a pan gets overheated, again, a fire risk, emphasizing the need to turn off ovens when not in use and not leave pans on stoves unattended. We mentioned earlier that a fire can start in a greasy ventilation hood. This could also assist the spread of fire to other places. The prevention is obvious. Keep the hood free from grease. This applies to all the equipment in the galley, and it is an essential part of good housekeeping. Electrical installations can cause problems. Too many connections to one point. The sockets and plugs are overloaded, heat up, could cause fire. Frayed wires, broken plugs, both could cause fire. Simply a bad connection arcing, it may be sizzling, could cause a fire. Remember the piece of material hung over the lamp to reduce the glare? Don't risk it. And with electrical equipment, remember you must pull out the plugs to the radio or other appliances when not in use. The engine room is an area highly susceptible to fire. It contains air, fuel, and heat. It is essential that the separation of these components is maintained. Do not permit oily rags to accumulate. Remember that cotton, if impregnated with oil, may spontaneously ignite. So may dirty linen in lockers. Rags should be put in closed metal containers for disposal and dirty linen stored on gratings to dissipate heat. An unusual example of spontaneous combustion is the oil-stained boiler suit that, having been washed, is left in the tumble dryer after the drying cycle is complete. Oxidation of the residual oil stains can occur and fire break out. Bilges should be kept free of oil and scrupulously clean. Engine room plates, too, should be kept free from oil. Lagging that has become oil impregnated should be replaced and any oil leaks reported or dealt with immediately. Baffle plates may be used to prevent oil leaks coming into contact with hot surfaces. Double skin pipe fittings, if properly maintained, do the same job. Dirty fuel burner tips are a serious risk. Oil drops may cause an accumulation of oil at the bottom of the furnace, which may cause an explosion. The golden rule is to keep tips clean, with regular cleaning and inspection. Engine rooms contain a good deal of electrical equipment which can provide sources of ignition if not properly maintained and regularly inspected. It is also extremely important to prevent water, steam leaks and condensation causing partial or complete short circuits with consequential fire risk. Procedures are laid down regarding the control of hot work, which must be obeyed. First, properly documented written permission, a permit to work, must be obtained from the officer in charge before welding commences. Care must be taken to ensure that there is no flammable material in the area to be worked on, and this includes behind, above and below the area. Suitable firefighting appliances and crew must be close at hand. On a tanker, before permission is given to weld on or close to a tank, the tank must be either fully inerted or gas-free and ventilated, as otherwise an explosion can occur. In a metal workshop, cleanliness is again essential, and it's wise to remember that accumulations of swarf, if covered with a film of oil, are liable to spontaneous combustion. Wandering electric leads are prohibited on deck in tankers. Something may drop on the lead and cause a short circuit, or rain may penetrate connections and be another source of danger. All electrical equipment should be protected by a correctly rated fuse. Modern circuit breakers increase electrical fire safety. In the holds especially, strict vigilance, careful stowage and careful consideration of cargo requirements is necessary. Coal itself can give off highly flammable methane gas, especially when freshly loaded. Regular checking of hold temperatures and atmosphere monitoring is important. Static electricity can cause fires. Before pouring flammable liquids such as varnishes, paint or kerosene into another container, make certain, by touching them together or to the metal of the ship, that they are electrically discharged. If on a tanker or similar ship, follow the instructions contained in the Code of Safe Working Practice or similar guide. Statistics show that many ship fires are caused by smoking or smoking materials, matches, lighters, smokers' pipes. Prevention of fire from these causes is therefore within the direct control of the persons involved. Remember, when you light a cigarette, you light a fire. Use self-extinguishing ashtrays. Never leave cigarettes, pipes or cigars alight anywhere. When emptying ashtrays, make sure they do not contain smouldering material. Never smoke in bed. If you feel you must smoke, get out of bed to do so and make sure before you get back in bed that the cigarette is completely extinguished. Tankers and other hazardous cargo ships comply meticulously with the special procedures laid down which forbid smoking other than in cabins, public rooms and the wheelhouse. Cigarettes or smoking and lighting materials must only be carried in the accommodation area. In port, while working cargo or tank cleaning, further restrictions limit smoking to one selected room for officers and one for crew. Equally important, any visitors must be warned before they come on board that they have to obey the smoking procedures, even to the point of having their lighters and matches taken from them before visiting the ship. In this film, we looked at the fire triangle of cause and effect, the nature and types of fire, and how fires may be started. Prevention is better than cure. Knowing some of the potential causes of fire and the way they spread from place to place, you are better able to prevent them. Most importantly, be fire conscious. Follow safe practice and maintain good housekeeping. If you see, hear or smell something that you think is not as it should be, report the matter at once. Never ignore the dangers of a faulty switch, the overfull waste bin, the smoky galley stove, the spilt oil in the engine room, the smouldering cigarette butt. the oily rags, the frayed or overloaded electric wiring. Think about the fire triangle and the fire hazards on your ship. In short, be aware. That way, you can contribute in large measure to fire prevention, the well-being of all aboard, and the safety of the vessel on which you serve. The Videotel Marine International program you have just seen is one of a series of 4 on firefighting at sea. Program 2 deals with basic firefighting, Program 3 with command and control at the incident, and Program 4 with command and control by the master. For further information, consult the publication Marine Firefighting and Prevention.